everyone for joining today and spending some time with us. Really appreciate it. I'm excited to talk about using Prefect and Coiled for deploying and scheduling, regularly scheduled workflows on the cloud. So for those who aren't aware, Prefect is a tool for taking Python code and converting that sort of easily in a straightforward way, converting that to production-ready workflows, and we'll see some examples of that today. And Coiled is good at deploying Python in general, and today we'll see that in the context of deploying Prefect tasks and workflows. So let me go ahead and share my screen real quick. Awesome. Hopefully you're seeing a VS Code session with some code in it, and the text is big enough. If any of that isn't the case, just let me know. So what we have here is sort of a straightforward Prefect workflow just to get a sense for what that looks like. So here I've got three functions: a get data function that returns a string. It just generates some random string data, prints it out, and returns it. And then we have a process function which takes in a string and just counts the number of times the letter A, for example, occurs in that string and returns that count. And then here I have a simple workflow function, which stitches those two functions together to form sort of again, kind of hello world level example. So we get the data here, we then take the data, pass that through to the process function, and then print out the final result here. And then if I wanted to run this workflow, I could, for example, just call it like a normal Python function, like so. And what you'll notice is like, this is all normal Python code that should look familiar to folks. The only real Prefect bits here are I added a flow decorator for the to sort of signal what the actual workflow is. And then I added on the individual tasks within the workflow, added these task decorators. So it's really, it's a really low bar to take some existing Python functionality and convert that into a workflow that has lots of nice things that you would expect with a workflow system. Automatic things like automatic retries, monitoring, logging, all serving things on a regular basis, all those niceties that you expect from a workflow management system. So yeah, let's not just run this once, but instead use Prefect to run this entire workflow just regularly. In this case, I'm saying, hey, Prefect, take this workflow and just run it every 5 seconds, just for example. So I can then go to my terminal, which again, hopefully the font is big enough for folks, but just run a simple, Python simple.py, that's the module this is in. And we can see that Prefect now has the flow, it's serving it. I can look at, there's like a nice web app that Prefect has where you can see some workflows that are currently running, some pending ones, the next workflow that's scheduled. And if I go back to my terminal, I can see the results being printed out. So here is one of those random data streams and how many times A appears in it. And I can see another results and another result and another result. And it's just going to run, indefinitely every 5 seconds. And again, I'm running everything here locally on my laptop. So anyways, hopefully that gives a good sense of what it's like to use Prefect. I'll go ahead and just cancel that real quick. Okay, so hopefully that gives a good sense of what it's like to use Prefect. Really, it's pretty Python native. It looks like normal Python code, which is a good selling point. So I ran everything here locally on my laptop, and it's nice because it's easy to get started that way. But lots of there are many cases in which you actually want to run things not locally on your laptop, but on the cloud. And there are sort of two common scenarios we see there. The first scenario is that you want to run an individual task in a workflow on the cloud. Maybe, for example, you're training a machine learning, you're training some PyTorch model that you want to train on a GPU, on some hardware that you don't have locally, or you're doing some data processing where you need more memory than you have locally on your machine. So we're going to show how we can use Coiled to take an individual task and dispatch that to run just that task on a cloud VM of your choosing. So that's the first scenario we commonly see is individual task. I want to run that on the cloud. A second example is you actually want to run the entire workflow on the cloud. You want to that we most often see that for long running workflows. So, I want to run this workflow once a day. Prefect, please run that once a day for me. That's very easy to have Prefect do. But I also may want to close my laptop at some point or restart it or something. So not having everything tethered to my local machine can be really useful for those long running scenarios. Okay, so let's go ahead and now that we have sort of a basic understanding of what it looks like to run Prefect, let's now look at a example where we use Prefect and Coiled together to run Prefect on the cloud. So that's here in this workflow. So this example is a little more involved, although the overall sort of structure and pattern is exactly the same as the simple one. Just the individual tasks themselves are a little more involved. In those tasks, what we're going to do in this workflow is analyze some NASA data. So NASA, for reference, hosts a bunch of publicly accessible data on the cloud on AWS. And we're going to look at one particular data set, this merge APL data set. This data set actually looks at sea surface temperature. So once a day, a satellite goes around the Earth and a new file lands in this bucket here, in this NASA bucket. And so what this workflow does is once a day, it looks for new files that are in that bucket that haven't been processed. It then processes all of our files, and we'll see that processing function, and then takes that processed data and writes it out to an output bucket here. And that happens again. The satellite goes around once a day, and so we run this workflow once a day. So let's look at the individual. Let's look at the workflow itself now. So here's a task where we get new data files. The details here aren't super important for all of this, so I'm just going to kind of give a high-level sketch. But what we do is we look at the NASA data set and we find all the files in that data set. We look at our processed data set. We find all the files there, and we basically just return the diff. What are all the files that haven't been processed yet? And then here's our processing function. So we use tools that are common in the earth science space. So tools like Earth Access, X-Array, a more generic tool like S3FS to take in our data file, load it, apply some quality cuts. So in this example, we look at a particular longitude, latitude slice on the globe of interest, particular region of interest, apply some additional data quality cuts, and take that process data and write it out to S3. So that's what the processing function does. And our workflow function stitches all those tasks together. We get all of our data files, and then we process them all. And then again, because this happens, a new data file lands once a day, we have this workflow run on a regular schedule once a day. So all of this should look, while the tasks themselves are different than the simple example, they have some sort of domain knowledge or science encoded in them. The overall structure is exactly the same as the simple example, with one exception. We've added this coiled function decorator here to our processing task. That's because this data set can actually only be accessed on directly on US West 2, and also I want to avoid inefficient and expensive data transfers from AWS. So I actually want my processing function to run on the cloud right alongside my data. So this coiled, just adding this coiled function decorator, now this function will not run locally. It will instead, coiled will automatically, we'll see this happen in a second, it'll automatically provision a VM for us of my choosing. Here it'll be in US West 2 on an instance that's large enough to process this data. It'll run this exact processing function on that VM. It'll get the result and then return it back locally here to my laptop. And all that, we get all that for free just by adding this coiled function decorator. So let's go ahead and I'm actually going to really quick remove some files that are in our process. Right now, all the files have been processed. So I'm just going to remove all of the files that are in March. So we'll have some files to, some new files to actually process. Great. So I've deleted all the files in March. Now let's reprocess them. So I'm just going to run my workflow here. So Python workflow.py, it takes a second to dispatch that to Prefect, and there it is. And I can go ahead and click the link here, go to the Prefect UI, and I can see the next scheduled job. Because it's actually going to take a day until it runs it, because I've said to run it once a day. So instead of waiting a day in silence with you all, I'm actually going to manually trigger. Any Prefect flow you can run on a scheduled job, you can also manually trigger it. So here I'm going to trigger one of those, say, hey, please run that workflow once for me. And we'll go ahead and refresh this, and we'll should see our new flow run appearing in just a moment. And there it is, it has started. So if I, again, refresh, here's that running workflow. I can see it's getting the new files here in this task. And that again is running locally on my laptop. I'm able to query the data set, but not access it locally. And then in a moment, we'll see that we'll have all the new files that are ready to be processed, and it will dispatch to our processing function. Yeah, so here we go. So we can see here are all these files to process. And those, because those are decorated with the coiled function, are not running locally on my laptop. Instead, if I go to coiled, I'll see that function is actually being provisioned here. And so what happened is Coiled, the first thing that happened was Coiled automatically scraped the local software environment I have installed. It found all the pip installed packages I have, all the conda installed packages I have, any Python, py files I have laying around. It packaged all those up, and it's replicating that same exact software environment on the cloud for me. If I can go back to the function itself, we can see I asked for this to be in US West 2 on a specific instance type, an M6I large instance type. I can see, it's in US West 2, there's my instance types. I have access to logs, a bunch of metrics, things like that. And what I'm seeing here is a nice time series. X-axis here is time, and the colors indicate the status of my VM. So I can see for a few seconds it was queued, then it was starting, then it was running. Currently, it's downloading all of that software that I have locally installed on my laptop, like things like Earth Access and Prefect and Coiled and XGBoost, things like that. It's actually installing those all locally onto this VM for me now automatically. This entire startup process, VM process, takes about a minute or two. And then once the VM is up, I then have access to it and can use it to run all of my tasks. And we can see here the VM is now ready and running. So I can go look at the dashboard for this particular VM, and what I'll see is processing tasks. So here's those 5 processing tasks for those 5 intro files. And we can see there I was processing 1 file, there's a 2nd file, 3rd file, and all the files have now been processed. I can go here back to my Prefect. It's like fun to kind of go back and forth between Prefect and Coiled and seeing all the pieces talking to one another. I can see here I've processed all my files. My workflow is printing out where they were. So here I can see all the individual, we're logging where all these files have been written out to. And then after a few seconds of this VM not doing any work, it's going to automatically shut itself down. So I don't have to worry about this being up and just sitting around idle for too long. Okay, so that's an example of the first scenario where we want to take an individual task and run it on the cloud using Coiled. Let's talk about the second scenario now, where I don't want to just run just a task on the cloud, but I want to run the whole workflow on the cloud. So okay, so here we can see locally again, I'm running my workflow. I'm going to go ahead and close that out. Stop that workflow running. And let me go ahead and so normally what I would do to run, what I just did to run the workflow was just run it like a normal Python script, Python workflow.py. Instead, if I want to take that workflow and run it not on my local machine, but on the VM on the cloud, what I can do is I can do coiled prefect serve. And that will take the same exact workflow and just run it on a VM. So there's some other things, other options we can specify here. For example, I'll want to put it in US West 2 to be alongside my data. This particular workflow, and actually many long-running workflows, the actual workflow like the workflow code itself doesn't require significant resources. It's actually, there's often some heavy duty individual tasks where the data processing happens, and those can be dispatched to larger VMs like an M6i X large or 8X large or whatever the case may be. That's where the heavy duty processing happens. But the always on VM can typically be pretty small. So that's actually important because it's always on. So you don't want it to be very expensive if it doesn't need to be. So here I can say, use a T3 medium instance. For reference, that costs about $1 a day to run. This workflow also is using, I mentioned earlier, Earth access, which requires some additional authentication. Locally, I have a file that has my credentials in it to access this NASA data, but I'll want to pass those through to this VM that's running on the cloud, so that VM can also access my data. So Coiled Prefect Serve has a -E flag for specifying environment secrets that are sort of securely transmitted to that VM. So I'm going to want to specify a few of those. I have that command here for me. So here I'm specifying some Earth data relevant secrets and some AWS secrets as well. Okay, so let's go ahead and run that. And what we'll see is Coiled is kicked in and it's running my workflow for me. Again, it's scraped my local software environment and packaged up everything that I have and pushed it off into the cloud for me. I've asked for it to be in US West 2 on a T3 medium instance, and that's what I'm getting. And then here, this progress bar is showing, it's sort of similar to what we saw on the Coiled web UI earlier. We can see the VM's currently starting. In a second, it'll be booted up and then start downloading the software environment and then running my Prefect workflow for me. So I get a nice view of that. And again, this whole startup process takes typically about a minute or two. That's about as fast as we can do all of those steps that I just mentioned. Another nice thing we get is uptime, how long the VM has actually been running for. And maybe we can see now it's been running for about 20 seconds. And even more importantly, maybe than that, we get a nice cost estimate of how much this VM is costing us. So we can see it costs about 10 cents an hour. And it's been running for 32 seconds. So yeah, we've yet to spend a penny, but eventually we'll spend a penny and then we'll see a 1 here. So we'll get that total approximate cost for this VM in addition to the rate. So we're currently downloading the software environment. I'll go ahead and click on that. And we can see things like metrics and, well, actually, that's not very interesting. Let's go ahead and nothing's run yet. Let's go back to the VM where our function ran before. And there's the function that ran. I can see interesting metrics like CPU over time, memory over time, disk over time, things like that, and also have access to logs, which is really useful in general. Okay, so if I go back to the Prefect workflow, I can see it's ready and running. It takes a second for the Prefect aspect or like the Prefect workflow to actually run. And okay, and there it goes. I can see the same output that I saw locally on my laptop. I now see here. Again, I want this to run now and not wait a day before it runs. So I'm going to go ahead and trigger a workflow. Oh, we'll probably want some files to process. Since they're all currently processed, again, I'll go ahead and just delete all the files from March. So we'll have some files to process. I'll then queue off a workflow run real quick. And we should see that happening in Prefect. If I go here, it'll be pending. It'll take a second. We'll see the same exact thing that happened locally on my laptop, but it'll be running instead on this always on VM on the cloud. So we'll just let that run. I'm taking a quick time note. Okay, great. So one last thing I wanted to show real quick is a larger example. So what I've shown so far is sort of a nice simple hello world example for Prefect, and then how to take a more involved example and deploy tasks, individual tasks, or the entire workflow on the cloud with Coiled. I just want to briefly mention that we're actually working on a much larger sort of production level ETL data processing example that shows off using these systems in other systems. So using Prefect, Coiled, Dask for larger data processing tasks, sort of modern data formats like Parquet and Delta Lake for storing data. There's a model training component and sort of a serving component where we're serving, for example, a Streamlit app where you can have a dashboard that's a live view of what's going on in the ETL system. And these things happen not just in the geospatial example we showed. It just had one workflow running, in that case, daily. This example has many different workflows running at different cadences, generating data, processing that data, training models, and those are all interacting with one another at different time cadences and things like that. So it's a much more sort of realistic example. It looks familiar, like what we just showed. For example, we have workflows that are running at different cadences that are being served with Prefect. We're using coiled functions to, I can make the text a little bigger. We're using coiled functions to dispatch individual tasks on the cloud. And we're using a new component here is we're using Dask clusters that Coiled is deploying to run large scale Dask clusters for bulk processing of our data set on the cloud as well. So just kind of giving this kind of as a tease for an upcoming webinar. We'll talk more about using things like Dask and Coiled and Prefect together for production environments. So if folks are interested, this is a totally public repo. Again, this is still a work in progress. But if you're interested, feel free to check it out. It's coiled/ETL TPCH, if anyone's interested. And again, we'll be talking about this particular example in a future webinar. All right, last thing I wanted to mention was thank you all for coming and for the time. If you're interested in learning more about Coiled, I recommend going to docs.coiled.io if you'd like to learn more. Our Prefect document integration documentation is there as well if you'd like to dive into any more details related to what we've shown today. I also want to mention, importantly, it's free to get started with Coiled. So we have got a pretty robust free tier, so it's easy to try things out and see if it fits your use case well. So with that, I'll say again, thank you all for the time today. Really appreciate it. And we can open up for Q&A. I'm curious what questions folks may have.
Thanks, James. I answered a couple questions while you were giving your demo. We'll see, if any other questions pop up for folks. Can wait a couple minutes for things to trickle in. In the meantime, I wanted to share a couple links. So I just dropped a link to our documentation in the chat. And I also wanted to share specifically one of the Prefect examples that James walked through. You can find a lot of this in our documentation. And then I also wanted to drop a link to the sort of in progress example that James alluded to at the very end there, that ETL TPCH repo, where some more work is being done, but we'll be talking about that in the future. So cool. So we've got a question from James Pauly. James says this could be a boring question, but so for secrets for the first task demo example, were those passed to AWS in the same way as was shown via the CLI in the second example?
Yeah, so in the first example, so I guess I don't know how. Yeah, in the first example, I didn't pass any AWS secrets. That was done automatically for Coiled. So Coiled, just like it handles automatic package synchronization between my laptop and the cloud VMs, it also handles automatic cloud credential forwarding from my laptop to the VM. But it will actually only do that when we don't like copy your credentials and send them like your secret and access key and forward those off. We do it in a more secure way. We generated an automatic token that expires periodically, and we make sure that that is refreshed on the cloud VMs. So in the first case, when things were running on my laptop, there's always a connection with my laptop, so we can do that refreshing automatically. In the second case, where we deploy things just on the cloud VM, we ask users to manually opt in to giving us relevant AWS credentials. For security reasons, we're not going to just take your permanent AWS credentials and transfer them to the machine. So that's why, to the cloud VMs, that is. So that's why in the second case, we specified them manually. Great question, though. In both ways, they're securely handled. Just also an important point to mention. But thanks for the question, James. Thanks again, everyone, for the time. Really appreciate it. And hopefully see you next time.
Thanks, James. Thanks, everyone.
Thanks, Eric.